So I decided to calculate the thermal resistance of the both LEDs that I made measurements for in the last video. One of them is the CREE LED CXA3050, which is this one here in this thermal image, and the other LED is a COB LED rated at 50 watts. As I studied in the previous video, I used two fans with different air speeds to see the difference in temperature that this would cause. So for this analysis, I used all the measurements that I obtained for that video. And in this case, what is important is that I used this temperature here, obtained by the thermal camera, and I compared it to the temperature obtained by the thermocouple. This way, I am normalizing this temperature with respect to the temperature obtained by the thermocouple, and I would get a better approximation of the real temperature, because this value is normally not very precise. It gives a good idea, but it's not very precise. So having said that, I calculated this difference, and for example, this is the column that I got for the CREE LED. This is the column for the COB LED, considering this difference. I use this difference to calculate the possible temperature at the light emitting surface, which is this surface specifically, the one that actually is shining. And using this knowledge and the power given to the LED, I calculated a possible, this is here it says electric is thermal resistance, the thermal resistance, and I just averaged those values, and I got a value of 1.14 degrees centigrade per watt for the CREE LED and 1.62 degrees centigrade per watt for the COB LED. As I expected, the value for the COB LED is greater than for the CREE LED. So that's it for this week.